Hello everyone, I'm Hilary from K2S1, Group 40. My group consists of 5 members who are Kiu Sie Dak A20EA0047, Hakimi, Nurfatin, Amni, and also Muhammad Ali. Today, I'm going to present about the main subfield in the discipline, which is geotechnical engineering. Basically, the information that I discuss with other team covers the all 4 assignments, and also we do share our knowledge on civil engineering with one another. So first of all, let me introduce the definition of geotechnics. Geotechnics is an engineering discipline that from scientific viewpoint deals with soil and rock behavior. It also includes determining the stability of slope and also the danger of landslides, falling rocks, and also avalanches. Geotechnics requires the study, design, and also construction without restriction of foundations, cliffs, retaining walls, embankments, and other systems consisting of supported by soil or rock. Geotechnical engineering program is also offered as a master degree in civil engineering. So now let us look at the scope of work in geotechnical engineering. First of all, they have to guide and maintain the Earth's physical environment during project development. Besides that, they have to do analysis and mapping of the scientific findings of seismic surveys and also evaluate layers of underground water trapped in rocks. Thirdly, they have to do the study of soil strength, drill hole stability, stress restriction, rock formation permeability, and also the degree of trapped hydrocarbons in underground reservoirs. In order to be a successful geotechnical engineer, there are many challenges in geotechnical engineering, which you have to overcome it. Um, Let me give you some examples of the challenges in geotechnical engineering. First of all, weather condition and limited number of test holes, limited depth of test holes, field material and water table, emergence of new waste forms, long-term performance of water waste containment system, and also increasing significance of biological processes. So, those who want to be a geotechnical engineer, you have to face the challenges and beat the challenges. That's all from me. Thank you.
Assalamualaikum and very good morning. My name is Haikal Hakimi bin Kharudin. I'm from Group 40, Section 4, SEAA1011. So, my group members are Hilary Lozesin, Kiu Sie Dak, Nurfatin Amni binti Anuar, and Muhammad Ali bin Muhammad ASRI. So, today I would like to present transportation engineering. Transportation engineering is a branch of civil engineering that is involved in the application of technology and scientific principles to the planning, functional design, operation and management of facilities in order to provide the safe, comfortable, convenient and economical movement of people and goods. The working field for transportation engineering includes highways, traffic control, public transit systems, railroads, waterways, airports and also bridges. So what do transport engineers do? Transport engineers determine the traffic impact caused by new development plans. They also research and evaluate traffic volume, accidents practice and efficiency. They also provide recommendations for traffic policies. They also identify solutions for transportation problems. And last but not least, transport engineer design new means of transportation. The common issues faced in transport engineering, such as manage proper maintenance of the roadways, handling traffic flow to minimize congestion, prevent transportation accidents, facilitating efficient trade routes, provide safe options for pedestrians, and also determine the fastest way to transport goods. There are so many issues that were faced by transport engineer, such as bridge collapse and road collapse. This bridge collapse and road collapse will happen due to flooding. So how can flood cause bridge to collapse? Floods cause bridge collapse in different ways. When the river passes under a bridge, the high water level smash the bridge into a bridge. The weight of the pile up combined with the force of flowing water pushing on it can bring the bridge down. Flooding can also collapse the bridge by gradually wearing away the earth around and underneath bridge piers. This process is known to bridge engineers as core and occurs whenever bridge foundations are placed underwater. Next, how can flood cause roads to collapse? Road collapse usually caused by washout, which means a sudden erosion of soft soil or other subsurface, occurring during a heavy downpour of rain or stream flooding. A severe washout can become landslide. A washout may destroy a road by eroding away the roadbed caused by flowing water. So how can transportation engineering prevent bridge collapse? Whenever there is a problem, there is also a solution. So transport engineer design bridge higher than historic flood levels to avoid the possibility of lift supports and debris collisions. They test scale models with comparable materials under rigorous conditions. These conditions allow water or large debris to pass through bridge, creating better resistance during floods. So that's all from me about transport engineer. Thank you and have a nice day.
A very good morning to my beloved lecturer and all my friends. My name is Kiu Sie Dak. I'm from Section 4, K2S1, Group 40. My group members includes Haikal Hakimi, which is our group leaders, Hilary Law, Nurfatin Amni, and lastly Muhammad Ali. During the meeting with Group 7 and 8, we have discussed about information on geological engineering, geotechnical engineering, transportation engineering, soil and structural engineering, and lastly, water resource engineering. So today I would like to present about my title, which I'm involved in, which is environmental engineering. Environmental engineering is a job type that is a professional engineering discipline and takes from both scientific topics like chemistry, biology, ecology, geology, microbiology, and mathematics to create solutions that will protect and also improve the health of living organisms and improve the quality of the environment. Environmental engineering is a sub-discipline of civil engineering and chemical engineering. Environmental engineering is the application of scientific and engineering principles to improve and maintain the environment to protect human health, protect nature's beneficial ecosystem, and improve environmental-related enhancement of the quality of human life. Environmental engineering devise solutions for wastewater management, water and air pollution control, recycling, waste disposal, and public health. They design municipal water supply and industrial wastewater treatment system and design plans to prevent waterborne disease and improve sanitation in urban, rural, and recreation area. They evaluate hazardous waste management system to evaluate the severity of such hazards, advise on treatment and containment, and develop regulation to prevent mistake. They implement environmental engineering law as in assessing the environmental impact of proposed construction project. Enviro Environmental engineers also study the effect of technology advance on the environment, addressing local and worldwide environmental issues such as acid rain, global warming, ozone depletion, water pollution, and air pollution from automobile exhaust and industrial resource. So that's all for my presentation about environmental engineering. Thank you.
I'm Nurfatin Amni, and I'm going to share with you about water resource engineering. So what is water resource engineering? Water resource engineering is an analysis and design of systems or structures to control water in terms of quantity of water, quality of water, the timing of water supply, and the distribution of water. Water resource engineers are responsible for the planning, design, operation, and management of surface and groundwater system, preservation and enhancements of the natural river and watershed environment, design and construction of water control facilities, and lastly, conservation of water resource. What is a water resource system? It is a structure or facilities that are able to treat, store, and convey water to where it is needed, when it is needed, and to the purpose for which it is needed. There are two categories of water resource system, which is water control and water use system. Types of water control system are drainage, flood control, and water supply, while the type of water use system are wastewater treatment system, irrigation, and hydropower generation. Next is coastal engineering. What is coastal engineering? Coastal engineering is a branch of civil engineering concerned with the specific demands posed by constructing at or near the coast, as well as the development of the coast itself. There are a few threats in the coastal zone, which is beach and coastline erosion, river mouth sedimentation, extreme storms, sea level rise, tsunami wave and inundation, and lastly is environmental threats such as oil spill, depleted ecosystem. Do you know that coastline can move? Why do coastline move? It is because the relationship between sediment, wind, and water. Wind creates wave and surface currents. Wave and currents induce the shear stress on the bed. The sand, SRB, and other bed materials resuspended into the water, and these are transported within the coastal circulation system. Lastly, there are a few coastal erosion protection strategies, such as seawall or revetment, groin, detached breakwater, submerged breakwater, and beach nourishment. The conclusion we can get from this topic is we need to save water and use it with responsible. This is because thousands have lived without love, but no one lived without water.
Assalamualaikum, my name is Muhammad Ali. So I will talk about structural engineering. So structural engineering is a subdiscipline of civil engineering in which structural engineers are trained to design the bones and muscles that create the form and shape of man-made structures. Structural engineers need to understand and calculate the stability, strength, and rigidity and earthquake of built structures for buildings and non-building structures. The structural designs are integrated with those of other designers such as architects and building services engineer, and often supervise the construction of projects by contractors on site. They can also be involved in the design of machinery, medical equipment, and vehicles where structural integrity affects functioning and safety. Structural engineering theory is based upon applied physical laws and empirical knowledge of the structural performance of different materials and geometries. Structural engineers structural engineering design using a number of relatively simple structural concepts to build complex structural systems. Structural engineers are responsible for making creative and efficient use of advanced structural elements and materials to achieve these goals. Structural engineers Structural engineering depends upon a detailed knowledge of applied mechanics, material science, and applied mathematics to understand and predict how structures support and resist self-weight and impose loads. To apply knowledge successfully, a structural engineer generally requires detailed knowledge of relevant empirical and theoretical design code, the techniques of structural analysis, as well as some knowledge of corrosion resistance of the materials and structures, especially when those structures are exposed to the external environment. Structural engineers often specialize in particular types of structures such as buildings, bridges, pipelines, industrial tunnels, vehicles, ships, aircraft, and spacecraft. Structural engineers who specialize in buildings often specialize in particular construction materials such as concrete, steel, wood, masonry, alloys, and composites, and may focus on particular types of buildings such as offices, schools, hospitals, residential, and so forth. The role of a construction engineer today involves a significant understanding of both static and dynamic loading and the structures that are available to resist them. Okay, that's all from me. Thank you.